and welcome to this session. Understanding RS flip-flops and their construction using IC 7400 is pivotal in grasping the backbone of digital circuitry. Mastering these fundamentals lays the groundwork for designing complex circuits crucial in various electronic devices from timers to advanced computing systems.
Objectives. At the end of this session, you will be able to construct and test clocked RS flip-flop using IC 7400. Before we begin assembling our circuit, let's ensure we have all the necessary tools, equipment, and materials at hand. For this, we will need the following tools and equipment. Digital trainer kit 1 number, digital multimeter with probes 1 number, wire stripper 1 number, tweezer 1 number. We will need the following materials and components. IC 7400 NAND gate 1 number, hookup wires as required. Let's now look at what a clocked RS flip-flop is. If the reset and set input wires of a flip-flop only control the outputs when a clock pulse occurs, going either low to high or high to low, then this is called a clocked RS flip-flop. Since the clock signal synchronizes and coordinates the timing of when the set and reset inputs can impact the outputs, this type of flip-flop is also known as a synchronous SR flip-flop. In the clocked RS flip-flop, the Q output will be unaffected by any change in R or S as long as the clock CLK is 0 or low. When clock is high, S is equal to 0 and R is equal to 0, the output of NAND gates C and D are S bar is equal to 1 and R bar is equal to 1. Hence, the outputs of the NAND gates A and B remain unchanged. This is called hold state of the SR flip-flop. When S is equal to 0 and R is equal to 1, the output of the NAND gates C and D are S bar is equal to 1 and R bar is equal to 0. The output of the NAND gate A is 0 and that of NAND gate B is 1. This is called reset state of the RS flip-flop. When S is equal to 1 and R is equal to 0, the output of the NAND gates C and D are S bar is equal to 0 and R bar is equal to 1. The output of the NAND gate A is 1 and that of NAND gate B is 0. This is called set state of the RS flip-flop. When S is equal to 1 and R is equal to 1, the output of the NAND gates C and D are S bar is equal to 0 and R bar is equal to 0. The outputs of both NAND gates A and B try to become 1, which is not possible. This is called forbidden state of the RS flip-flop. Let's now look at the procedure of construction and testing a clocked RS flip-flop using IC 7400. Collect all the required components to build the clocked RS flip-flop. This includes the digital IC trainer kit, one 7400 quad 2 input NAND gate IC and some jumper wires. It is necessary to check all the required sections of the digital IC trainer to ensure its working condition. This includes the plus 5 volt power supply, input switches, breadboard, and the output LED indicators. Make sure to thoroughly inspect each part and verify you have the full set before beginning assembly. Carefully insert the 7400 ICs into the breadboard located in the digital IC trainer kit and ensure that all the pins are aligned properly. Connect the plus 5 volt supply of the trainer kit to the positive terminal of the breadboard. Connect the 14th pin of the IC to the power supply. Connect the ground of the trainer kit to the negative terminal of the breadboard. Also connect the 7th pin of the IC 7400 with ground. The 2nd and 4th pin of IC 7400 are coupled together. This is connected to switch 3 with clock input located in the trainer kit. Connect the first pin of IC 7400 with switch S1 located in the trainer kit, and this is marked as S input. Also, connect the 5th pin of IC 7400 with switch S2, and this is marked as R input. The output obtained from the third pin is connected directly to input pin 9. The output obtained from pin 6 of IC7400 is connected directly with input pin 13 of IC7400. Connect final output Q pin 8 of IC7400 to the input pin 12 of IC7400 in cross-coupled feedback connection manner. Connect final output Q bar pin 11 of IC7400 to input pin 10 of IC7400 in a cross-coupled feedback connection. Obtain the corresponding outputs from the output LED indicators Q and Q bar and connect with pin numbers 8 and 11. Now power up the circuit and use the switches to apply high and low logic levels to the R and S inputs in different combinations. Observe corresponding latch state changes on the output LEDs. Whenever the clock signal is low, the inputs S and R are never going to affect the output. The clock must be high for the inputs to be active. When the clock signal is high, S is equal to 0 and R is equal to 0, output Q and Q bar remain in their previous states. When the clock signal is high, S is equal to 0 and R is equal to 1, output Q becomes 0 and Q bar is 1. Such a state of flip-flop is called reset condition. When the clock signal is high, S is equal to 1 and R is equal to 0, output Q becomes 1 and Q bar is 0. Such a state of flip-flop is called set condition. When the clock signal is high, S is equal to 1 and R is equal to 1, output Q and Q bar becomes 1, that is invalid state.
This brings us to the end of this session. In this session, we have learnt construction and testing of clocked RS flip-flop using IC7400. Thank you for watching. We'll see you in the next session.